When we open Symphony, we first see the main test setup window. In pin setup, we define our pins and assign them to groups. We also set logic levels and timing. In run setup, we can set the test rate and other run-stop conditions. In power setup, we would set our voltage levels and current limits for DUT power supplies. Symphony uses sidebars with icons to navigate through the software. When we select a different tab in the sidebar, we have available a new set of tools. Certain windows allow us access from the command bar to functions that control features of that window. In the toolbar, we have additional tools that apply to certain windows and become highlighted as those windows are open. Now let's open a file that has already been prepared for us. By using the File Open function, we can select a set file. The set file contains all of the setups in the software for a given device. Select this file and click Open. The next window that opens is the Download Vectors window. Our set file has an association with a given vector file. We can either just download this file, or we can click Browse to look for another. We can also uncheck this box and not download a file at all. But in this case, let's download these vectors. Now we see some new information has appeared in the pin setup window. In Group 1, we have a single DUT output pin, called TC. The compare threshold level has been set to 2 volts. And in delay generator number 2, a value of 30 nanoseconds has been assigned for the compare strobe. In Group 2, we see 4 DUT output pins, Q0 through Q3. In Group 3 is the clock pin. This is an input, and so we define low and high logic levels for the tester drivers. We select it as DUT input, and we choose a stimulus format, return to 0. Using delay generators 6 and 7, we define the pulse width of our clock. Now let's click the Pins button to look at some of the other pins. When the pin assignment window opens, we see Group 3 displayed. We see the signal name, the DUT pin number, and the tester system channel. We can scroll up to see other pin names and definitions. We see which group they're in, and the name of the signal, the DUT pin number, and which tester system channel is being used. We can also take a look or assign these names. We can type in a name here and assign it to the pin. We can also do the same thing with the DUT pin number by typing in the value and assigning it to the pin. We can continue to assign our pins in this way, but let's look at an easier way. On the main sidebar, let's select the pin list icon. This opens the pin list import window, where we can create a list if we've already got a set file, or we can open a pin list. Let's open the pin list for this device. And next we view the pin list. The pin list file is a standard ASCII file. In it, we can optionally identify the set file and vector file. The basic rules are: the first columns identify tester system channels. The next columns are the DUT pin number, followed by the signal names. We also can divide the pins into groups here and identify whether they are inputs, outputs, or bidirectional. The items after the semicolons are basically comments, showing the timing and edge placement. The pin list can hold a great deal more information than just pin assignments. Let's take a look at a larger pin list file. Here we see a great deal more information. We see the pin list as before, but also we can see DUT power supply settings, stop vectors and run conditions, and the test rate. We also see timing generator values and complete group definitions, including leading and trailing edges, logic levels, and programmable load settings for all groups. We can also have definitions for our DC parametric tests. We'll see more on the DC parametric tests later on, but the power of the pin list is certainly clear. When we click Execute, the pin list is imported into the system just like a set file. We can see that our power supply voltage has been set to 5 volts, as directed by the pin list. In Run Setup, our test rate has been set to 10 MHz. Our stop vector and last vector have been both set to vector 90. Let's move on to the next section now and learn about vectors and translation.